Can you imagine a future where the human body can heal itself from any injury or disease? Picture a world where the ravages of age, the damage from accidents, and the devastation of disease could all be repaired not with artificial replacements, but with your body's own natural ability to regenerate. This isn't science fiction. This is the promise of regenerative medicine. Regenerative medicine is a rapidly evolving field that seeks to harness the body's innate power to heal and restore. It's a different approach from traditional treatments, which often focus on managing symptoms or replacing damaged parts. Instead, regenerative medicine aims to repair, replace, restore, and regenerate damaged tissues and organs. Imagine suffering from a heart disease. Traditionally, you might require a heart transplant, which depends on donor availability and comes with its own risks. But in the realm of regenerative medicine, the damaged heart tissue could potentially be repaired or even regenerated. This transformative potential extends to a wide range of conditions, from spinal cord injuries to degenerative diseases like Parkinson's. Regenerative medicine could also revolutionize treatments for common injuries. Consider a torn ligament, which currently might require surgery and a lengthy recovery period. With regenerative techniques, the body could potentially heal the tear naturally and faster, reducing the need for invasive procedures and long recovery times. And it's not just about healing existing damage. Regenerative medicine could also help prevent disease and slow down the aging process. By rejuvenating cells and tissues before they wear out, we could potentially maintain our health and vitality for much longer. Just think of the possibilities: a world without organ donor shortages, a world where injuries heal faster and degenerative diseases are halted in their tracks, a world where we can live longer, healthier lives. This is the groundbreaking vision of regenerative medicine. It's not without its challenges, and it's still in its early stages, but the potential is enormous. As we delve deeper into this fascinating field, brace yourself for a journey into the future of healing. Welcome to the future of healing. Welcome to the world of regenerative medicine. At the core of regenerative medicine are the body's most versatile cells, the stem cells. Imagine an artist with an empty canvas and an array of colors to choose from. The artist can mix and match these colors to create any image they desire. Similarly, stem cells are like the body's paint palette, versatile and potent, ready to transform into any cell type the body needs. So, what exactly are stem cells? They're unique cells with the incredible ability to divide and differentiate into almost any type of cell in the human body. From the neurons in your brain to the muscles in your arm, stem cells are the origin. They're the body's raw material, the cells from which all other cells with specialized functions are generated. Stem cells come in different types and from various sources. Embryonic stem cells, for instance, are derived from embryos in the early stages of development and are pluripotent, meaning they can develop into any cell type. On the other hand, adult stem cells, found in mature tissues like bone marrow or fat, are multipotent. They can only turn into a limited number of cell types related to their tissue of origin. Then there are induced pluripotent stem cells, or iPSCs. These are adult cells that have been genetically reprogrammed to act like embryonic stem cells, offering an ethical and potentially unlimited source of versatile cells. So, how do these cells come into play in regenerative medicine? Well, scientists can manipulate stem cells in a lab to specialize into specific cell types. Then, these specialized cells can be used to regenerate and repair diseased or damaged tissues in people. Imagine healing heart tissue after a heart attack, or regenerating nerve cells in patients with spinal cord injuries. The potential is extraordinary. As the building blocks of regenerative medicine, stem cells hold promise for limitless healing possibilities. Imagine creating a beating heart or a functioning liver in the lab. It sounds like a concept straight from a science fiction novel, doesn't it? But this is the promising reality of tissue engineering, a cornerstone of regenerative medicine. Tissue engineering is an innovative field where scientists literally craft life in the lab. It's all about creating functional tissues and organs outside the human body, which can then be transplanted into patients in need. You might wonder, how is this possible? Well, the fundamental process involves combining cells, often stem cells, with highly porous scaffold materials. These scaffolds provide a three-dimensional template for the cells to grow, replicate, and eventually form a tissue structure. Now, this isn't as simple as mixing cells and scaffold together and waiting for an organ to pop out. It requires precise control over the cellular environment, including factors such as temperature, oxygen levels, and nutrient supply. Scientists also need to use the right types of cells, guide their growth in the right directions, and ensure they mature into the correct types of tissues. It's a complex and intricate dance of biology and engineering, but the payoff is worth it. Lab-grown tissues and organs have the potential to revolutionize healthcare. Imagine a world where organ donor shortages are a thing of the past, where patients waiting for transplants can receive custom-made organs tailored to their bodies without the risk of rejection or the need for lifelong immunosuppressive drugs. There's more. Tissue engineering isn't just about creating replacement parts for the body, it's also a powerful tool for medical research. Lab-grown tissues provide scientists with a way to study diseases in a controlled environment, test new drugs, and better understand human biology. In essence, tissue engineering is about creating new possibilities for healing, for understanding, for life itself. It's a testament to the incredible advancements in science and technology, and the relentless human pursuit of knowledge and betterment. Through tissue engineering, we are inching closer to solving the organ shortage crisis. And beyond that, we are opening up a world of potential for the future of medicine. From healing wounds to treating neurodegenerative diseases, regenerative medicine is making its mark. It's no longer confined to the realm of science fiction, but is instead creating a new reality of healing and recovery for countless patients. Take, for instance, the case of wound healing. Traditionally, this process can be slow and fraught with complications, especially for those with underlying health conditions. Regenerative medicine, however, is transforming this process, using innovative techniques such as skin grafts grown from a patient's own cells. These grafts not only speed up the healing process, but also reduce the risk of infection and rejection, making recovery smoother and faster. Next, let's delve into the field of cartilage repair, a common concern especially for athletes and older adults. Previously, the options were limited and often invasive, with mixed results. But today, thanks to regenerative medicine, we're seeing the use of stem cells and tissue engineering to rejuvenate damaged cartilage, offering a less invasive and more effective solution for those suffering from joint pain and mobility issues. And then there's the groundbreaking work in treating neurodegenerative diseases. Conditions like Parkinson's and Alzheimer's, once considered irreversible, are now being challenged by the advances in regenerative treatments. Researchers are now capable of using stem cells to regenerate lost neurons, offering a beacon of hope to those affected by these devastating diseases. Moreover, the impact of regenerative medicine extends to the treatment of heart diseases. Through bioengineered cardiac tissues, scientists are now able to repair damaged heart muscles and potentially save millions of lives each year. But it doesn't stop there. These are just a few examples of how regenerative treatments are being implemented in practice, each one a testament to the incredible potential of this field. From restoring sight through retinal regeneration to growing new organs for transplantation, the possibilities seem to be endless. These real-world applications are just the beginning of what regenerative medicine can achieve. As we continue to unlock the secrets of the human body and its extraordinary capacity for self-repair, we're not just redefining the boundaries of medicine but also our understanding of life itself. Genetics play a crucial role in regenerative medicine, opening up avenues previously thought impossible. The intersection of genetics and regenerative medicine is a fascinating one, where scientists are wielding the power of gene editing technologies like CRISPR to unlock new potentials in healing. CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats, is a tool that allows scientists to edit genes with unprecedented precision. It's like having a molecular scissors that can cut and paste DNA sequences, enabling us to modify the genetic code of life itself. This technology is revolutionizing regenerative medicine by giving us the ability to correct genetic defects, enhance the functionality of stem cells, and create specific cell types needed for regeneration. For instance, genetic manipulation can overcome some of the limitations of regenerative treatments. Some diseases are caused by a single faulty gene. By using CRISPR, it's possible to correct this error at the source, essentially curing the disease at the genetic level. This is a significant advancement from traditional treatments that only manage symptoms. Moreover, enhancing the functionality of stem cells through genetic manipulation can make regenerative medicine more efficient. Scientists can tweak the genes in stem cells to make them more robust or to differentiate into specific tissues more readily. This means we can potentially regenerate damaged tissues or organs more effectively and at a faster rate. Creating specific cell types is another area where genetics is making a big splash. For instance, creating insulin-producing cells to treat diabetes or neurons to treat neurodegenerative diseases could be game-changing. This can also help in creating lab-grown organs for transplantation, eliminating the need for donors and the risk of rejection. The fusion of genetics and regenerative medicine is not without its challenges. It requires a deep understanding of the human genome, and there are ethical considerations as well. But the potential benefits are enormous. We are on the cusp of a new era in medicine, where we can not only treat but potentially cure a wide range of diseases. With genetics, the possibilities of regenerative medicine are being redefined. The human immune system, while a vital defender, can also pose challenges for regenerative treatments. This paradox forms a significant hurdle in the field of regenerative medicine. When we introduce new cells or tissues into the body, the immune system may perceive them as foreign invaders, leading to an immune response that rejects the therapeutic cells. This is where the complexity of immune rejection comes into play. It's a bit like trying to get past a highly discerning bouncer at an exclusive club. The bouncer in this case is the immune system, and the club is our body. The immune system is incredibly good at recognizing what belongs and what doesn't. And while this is typically beneficial, protecting us from harmful pathogens, it can also hinder the acceptance of beneficial regenerative treatments. But fear not, science is on the case. Researchers are working on a range of strategies to outwit the immune system's bouncer. One such approach is to use cells from the patient's own body, a method known as autologous transplantation. Since these cells are not foreign, they're less likely to be rejected. However, this method is not always feasible, particularly when dealing with genetic disorders or when the patient's cells are too damaged or diseased to use. Another approach involves the use of immunosuppressant drugs to temporarily dampen the immune response. Yet this method isn't without its drawbacks, as it can leave the patient more susceptible to infections. Perhaps the most promising strategy involves modifying the therapeutic cells to make them invisible to the immune system, or to convince the immune system that these cells are not a threat. This is achieved through sophisticated gene editing techniques, which we touched upon in our previous segment. Despite the challenges, the quest to overcome immune rejection is of paramount importance. After all, the success of regenerative medicine hinges on our ability to introduce new cells or tissues without causing harm or provoking an adverse reaction. Overcoming immune rejection is a crucial step towards making regenerative treatments a reality for everyone. With great power comes great responsibility, and regenerative medicine is no exception. As we delve deeper into the realm of regenerative medicine, we encounter a labyrinth of ethical considerations and regulatory challenges. The power to repair, replace, and regenerate human tissues and organs is indeed groundbreaking, but it also raises a multitude of ethical questions that cannot be ignored. At the forefront of these concerns is the use of stem cells. While stem cells hold the key to tissue regeneration, their procurement, particularly embryonic stem cells, is mired in ethical debates. Some argue that the potential benefits outweigh the moral concerns, while others staunchly oppose the destruction of embryos for research. This underscores the need for a balanced approach that respects the sanctity of life while also unlocking the potential of regenerative medicine. Then there's the issue of access and equity. As regenerative treatments evolve, there's the risk of a divide between those who can afford these potentially life-altering therapies and those who cannot. To ensure a fair distribution, we must establish robust policies that prioritize accessibility and affordability. Moreover, the rapid pace of advancement in regenerative medicine presents a unique regulatory challenge. How do we ensure safety and efficacy without stifling innovation? This calls for an adaptable regulatory framework that can keep pace with scientific progress while safeguarding patient interests. Furthermore, with the advent of gene editing technologies like CRISPR, we're venturing into uncharted territories. The ability to edit our genes and potentially eliminate genetic disorders is awe-inspiring. However, it also opens up a Pandora's box of ethical dilemmas. Where do we draw the line between treatment and enhancement? How do we prevent the misuse of such powerful technologies? Finally, there's the question of consent. How can patients make informed decisions about treatments that are still in their infancy and whose long-term effects are not yet fully understood? Navigating these ethical considerations is as important as the scientific advancements themselves. As we continue to unlock the potential of regenerative medicine, we must also strive to build a framework of ethics and regulations that can guide us through this exciting yet complex landscape. Behind every scientific breakthrough are the individuals whose lives have been transformed. Let's take a moment to appreciate the human side of regenerative medicine. The science is fascinating, but the real magic happens when it touches lives, bringing hope where there was once despair. Imagine a world where a burn victim no longer carries the physical and emotional scars of their trauma. That's the world Maria lives in. After a devastating house fire, Maria was left with severe burns on over half her body. Traditional treatments would have left her with disfiguring scars, but thanks to regenerative medicine, she received a treatment that used her own stem cells to grow new, healthy skin. Today, Maria's skin is smooth and scar-free, a testament to the transformative power of this revolutionary field. Then there's James, a former athlete sidelined by a debilitating knee injury. He was told he would never run again. But through regenerative medicine, James received a treatment that used his own cells to regenerate the damaged cartilage in his knee. He is now back on the track, running faster and stronger than ever before. And let's not forget about Emily, who was born with a rare heart defect. A heart transplant was her only chance at life, but the wait for a suitable donor was painfully long. However, scientists were able to use her own cells to grow a new heart valve in the lab. Emily received her new heart valve and with it, a new lease on life. These are just a few examples among countless others. From burn victims to athletes, from newborns to the elderly, regenerative medicine is changing lives. It's giving people a second chance, a chance to live a full, healthy life, free from the constraints of their conditions. These stories bring to life the transformative potential of regenerative medicine. They serve as a powerful reminder that behind the science and the research are real people with real stories of triumph, resilience, and hope. These stories are the heart and soul of regenerative medicine, driving scientists, doctors, and researchers to continue pushing the boundaries of what's possible. These stories bring to life the transformative potential of regenerative medicine. Every revolution faces its share of hurdles, and regenerative medicine is no different. As wondrous as the promise of regenerating damaged tissues and organs seems, this innovative field of medicine is not without its challenges and limitations. One of the foremost barriers is the complexity of human biology. Our bodies are intricate systems where every cell, tissue, and organ has a unique role to play. Replicating the function of these biological structures outside the body, or even within the body, is a daunting task. It requires a precise understanding of the human body at a level that we are still striving to attain. Another hurdle is the risk of immune rejection. Even though scientists are making strides in developing techniques to overcome immune rejection, it remains a significant challenge. Our bodies are designed to protect us from foreign invaders, and they do not always recognize regenerated tissues as self, leading to rejection. Furthermore, there are challenges associated with scaling up the production of lab-grown tissues and organs. While it may be possible to grow small batches of skin or cartilage in the laboratory, creating larger, more complex organs like the heart or liver is an entirely different ballgame. It requires a lot more resources, time, and technical expertise. Then there's the ethical conundrum. As with any ground
groundbreaking medical advancement, regenerative medicine has raised a slew of ethical and regulatory questions. How do we ensure these technologies are used responsibly? How do we regulate the use of human cells and tissues in research and therapy? Despite these challenges, the field of regenerative medicine is advancing at a rapid pace. Scientists around the world are relentlessly working to overcome these hurdles. Every day brings new discoveries, shedding light on the mysteries of human biology and bringing us a step closer to the day when we can fully harness the body's regenerative powers. Addressing these challenges is key to unlocking the full potential of regenerative medicine. With every obstacle we overcome, we move closer to a future where the human body's ability to heal itself is no longer a marvel of nature, but a tool in the hands of medicine.
The future of regenerative medicine is not just about healing, it's about transforming the way we approach healthcare. Imagine a world where we no longer wait for organ donations, where the fear of rejection is a thing of the past, and where we can extend our lifespan. That's the promise of regenerative medicine. It's not science fiction, it's a future that's within our grasp. At the heart of this revolution is the ability to harness the body's own regenerative capabilities. We're on the brink of an era where we can replace damaged organs with lab-grown counterparts, crafted from a patient's own cells. This not only eliminates the need for organ donors, but also reduces the risk of organ rejection, a significant hurdle in transplant medicine today. But it's not just about organ replacement. Regenerative medicine holds the potential to heal chronic wounds, repair damaged cartilage, and even reverse the effects of neurodegenerative diseases. The possibilities are endless, and every day we're making strides towards making these possibilities a reality. As we move forward, the role of genetics in regenerative medicine is becoming increasingly important. Technologies like CRISPR are not only helping us understand the genetic basis of regeneration, but they're also allowing us to manipulate our genes to enhance our regenerative capabilities. Of course, this future doesn't come without its challenges. There are still many unknowns, and with every advancement comes new ethical dilemmas. But as we wrestle with these challenges, we must remember the transformative potential that regenerative medicine holds. In the end, it's not just about healing the sick, it's about redefining what it means to be healthy. It's about extending human longevity and improving the quality of life for all. As we unlock the secrets of regeneration, we're not just rewriting the book on medicine, we're reimagining the future of health. The future of healing is here, and it's more exciting than we could have ever imagined.